Okay, hello everyone. Thank you for tuning into this video. My name is Aljoscha Smolic. I'm lecturer at Hochschule Luzern in Switzerland, and I'm also co-founder of the startup company Volograms that is specializing in commercializing volumetric video. And it's my great pleasure to introduce you to our IBC 2022 accelerator project, which is entitled Volumetric Video for Broadcasting, Metaverse Production, and RT3D Assets. And it's basically centered around volumetric video, so something that you already see a little bit in this picture here. So it is typically something that is captured in a specific studio by a dome-type setting of cameras, synchronized cameras that capture the performance of some actor in a synchronized way, in a green screen setting typically. And then some algorithms operating on these pixels are converting this into a three-dimensional representation, most often such a three-dimensional mesh model, as you see here in this picture. So this is sophisticated algorithms of computer vision, computer graphics that make this asset creation happen. And once you have such an asset, you can use it wherever else you would use 3D computer graphics models, for instance, as content in AR applications, as you see here on the left, as a Snapchat filter. On the right, you see once again the nature of such content. So it's something that you know from computer graphics, a three-dimensional mesh model, but it's not made purely synthetically. It is reconstructed from real camera views. So this type of assets can be used for a variety of things. So here's the examples of AR applications. This can be user-generated content, but also professional content, marketing. Many types of different applications can be thought of here. So that led us also to the idea for this project that we want to report here about, our proof of concept, which will look at the question, how can volumetric video be interesting for professional broadcast applications? So for television, and more specifically even to certain types of sports shows, where you want to bring, for instance, a player as an asset into some visualization, let's say in a halftime show or in a pre or post show. So one requirement of such things is that it has to be fast turnaround, so you don't have the time to book a studio in advance and plan for a production weeks in advance, as it is typically the case with professional volumetric video studios. So you need fast turnaround, and you also have somewhat limited production costs. So under these circumstances, we asked ourselves the question, how can volumetric video be produced in a very fast turnaround and relatively expensive way? And luckily, Volograms released some technology that they call Volu. So it's an app that works on an iPhone that allows you to generate such content very, very quickly.
Hi, my name is Rafa Pajes and I'm one of the founders of Volograms. At Volograms, we're specialists in 3D reconstruction technology, specifically capturing of 3D humans, and with this technology that is called volumetric video capture. So what we've been doing essentially, it's revisiting the way that the 3D assets are displayed when they are in a broadcasting environment. So right now, what you typically have is a set of images or videos that are 2D. Normally they're keyed out, so the background is removed. And then in the studio, you can put them in 3D as if they were some kind of cardboard cutout of the player or of the character, which typically it's not very realistic. So what we're doing is that we're taking those images and those videos and we're generating 3D assets using our AI technology. So you don't need to go and take the football players or the rugby players and take them to a volumetric capture setup or anything like that. You can just use the images that you already have, the images that you have already been using for years, and you can even use images from other years. So you can essentially digitalize all your videos and all your photos and suddenly create 3D models that work really well when they are in the environment. So when they're in the studio, instead of behaving as a flat cutout that basically limits a lot the movement of the camera that the operator can do, you now have a 3D asset, and that 3D asset also can receive shadows, can cast shadows, you can change the different materials that you're using, you can create amazing visual effects, and that's essentially just using a very interesting algorithm developed by Volograms. So with that algorithm, we think, or with this system, we think that we can change the way this content is currently produced and is displayed in the in the broadcast environment, and we're extremely excited to work with all of these amazing companies, and looking forward to see what we're able to bring.
Yeah, so the specific things we want to see here is what are the requirements for the workflows, for the interfaces and tools in the professional environment, and also what are the limitations and best practices that arise from that. So we got together, one side, Volograms, who provided the content creation technology and did all the 3D reconstructions in this proof of concept. So we had two broadcasters on board, the Irish broadcaster RTE and Fox Sports, who basically provided the platform, the framework, and then used these assets in their professional environments. We also had help from VizRT, who is one of the providers of such professional hardware and software.
Hello, my name is Colin McElharney and I'm a broadcast engineer in RTE. We sent the 2D images to Volograms. Using their AI algorithm, they sent back the converted asset. We then brought the assets into the Viz environment where the Viz artist improved the JPEG quality. This was a manual process. This worked well as the Viz artist used a lookup plugin, which ensured the quality of the model is visible to the viewers. If investigated further in a later phase, we would ideally like to see a plugin developed that would bring the converted asset into a real-time graphic environment using AI to improve the quality of the image, to create reflections and to have controls for the operator to adjust certain parameters. This would improve the workflow for getting the volumetric asset on air.
I think one thing we're always trying to do at Fox Sports is create a unique visual difference. We talk about that all the time. And we look for tools that can heighten that production value that we're trying to achieve. And I think that's where Volograms can help out. It's, not just a 2D card that we've used in the past. It's something that, whether it's a football player, whether it's, an analyst wants to do a demo with a pitcher or a batter, it gives it a little more life and adds that production value that I was kind of talking about.
And also from our side, from the academic institutions, from Hochschule Luzern, we supported by conceptual advice, and also Trinity College Dublin finally made a user study where they asked professionals how they compare this content to the outcomes of this proof of concept.
Hello, my name is Gareth Young and I'm a research fellow at Trinity College Dublin. For this year's IBC, we've been exploring volumetric video for broadcasting Metaverse production and creating real-time 3D assets. The objective of my role on the accelerator has been to examine the impact of our focus on creating, delivering and applying digital humans on the viewing experiences of different audiences. To achieve this goal, we've been speaking to a variety of viewers to ascertain the potential of this technology to enhance media consumption practices. The cohort with whom we engaged displayed a variety of technical expertise using current technologies in media entertainment, but also self-described as being very good at using digital technology for consuming media, and were very familiar with the different technologies used in the media entertainment domain. To begin with, it was felt that the 2D graphical overlays added more informational context to what was being presented, but both 2D and 3D were considered equally adequate for the task. While the 2D content was described as smooth and polished, the 3D models provided a subjectively different experience because the audience felt as if the players were a part of the studio environment to a greater degree, even though the quality of the models was perceivably lower and had some noticeable artifacts. This factor was particularly evident when the camera moved around the studio because the 3D models were noticeably different at their edges from the rest of the studio scene. However, it was also noted that the 3D content didn't become distorted when the camera panned around the studio. They looked consistent from multiple angles, especially when the two volumetric characters were presented side by side. Still, some 3D objects, like the player floating in the air, were thought to be less successful in communicating presence in the studio. The comparison in the final example was needed for some of the audience to appreciate how 3D gives a better representation of the player on the screen, and one participant commented that it could be improved if we could mix the 2D infographics with the 3D models. The audience preferred the 3D assets, although some models needed refinement. The audience liked the realism of 3D, as the 2D assets look more like pictures, but without any background or context. Whereas with 3D, they could feel the presence, which was a much more enjoyable experience. Therefore, the 3D players felt qualitatively better, were more immersive, and provided a sense of depth in the studio.
And I would like to say in summary that everyone involved in this project really enjoyed it and learned a lot. So we know now much better how volumetric video can be useful, and we believe that there is a lot that that broadcasters can benefit from here.
I think it's going to be really exciting to watch this technology evolve. Tracking, scanning, these are things that have developed quite a bit over the years, and now to be able to see a program that can take something 2D and switch it to 3D so quickly and so accurately is it's rather remarkable. And I think that moving forward you'll see the development in that, in perhaps not only just the elements that you see on the screen, but also helping our artists create assets quicker. So whether it is an athlete, whether it's a model of a car, these types of things are going to continue to develop as AI, which is being used here, grows, and it's pretty exciting.